Okay, hello, hello, hello. I hope everyone had a great 4th of July. So we took a little bit of a hiatus. I ended up not posting your exam 2 until yesterday evening, and so I've made it available until Monday of next week. That's July 13th. So you've got a little bit of time here, but now it is time for us to forge ahead. I thought, what the heck? It was the holiday weekend, and you guys probably wouldn't mind, right? I doubt you minded. So anyway, it's time for us to get back to it, though. And so today we're starting into a new chapter, and it deals with energy from combustion. And so we have fuel. So if we talk about energy from combustion, it involves fuel. And what is fuel? Fuel is a high energy substance. And I do have something that I don't have written up here that I want to tell you about. I do have. Fuel is any solid, liquid, or gas that may combust, burn, to produce heat or to do work. Energy is the ability to do work, and heat is sort of the least useful form of work, but it is also a type of work. And so when we talk about using energy, in many cases it's going to involve producing heat, and we'll talk about coal-fired power plants. How do they produce electricity? By heating water to a boil and so forth. So heat and doing work. And what makes a fuel valuable, this is what isn't written up there, is the ability to be lit or ignited easily at low temperature and to produce large quantities of heat. So you can light it easily, and then once it gets going, once you start this chain reaction of releasing the stored energy in the molecule, it will then burn vigorously and vigorously release the energy stored there. So when we talk about energy from combustion, what are we talking about? Always fossil fuels. So we have a whole lot of fossil fuels. What is a fossil fuel? It's ancient solar energy. So fossil fuels, basically, they're not dinosaurs. No. We always say they're dinosaurs, but they're actually plants. So ancient plants from way back when that got buried underground and in a very low oxygen environment, and so the oxygen leaves, but it leaves all of the high energy components, and that's what is the fuel. I was just a quick aside, when I looked at my notes, I had talked about this 2 years ago when I taught this class, and I don't know if you ever watched the show Mythbusters. It's a kind of a crazy show related to this class because it dealt with mostly physics or a little bit of biological stuff. But someone came up with this question of whether earwax could be used to make candles. And this is the ability to do work, to produce light, right? No. But it was a funny episode and kind of disgusting in its own way. As you can imagine, they had to harvest earwax. But anyway, it is not a good fuel, but regular wax is. So we have all kinds of fossil fuels, the coals, your gas, your liquid gasoline, the oils, and we have what else? Propane, charcoal. All of these are going to involve burning. Now, the chemical formula for combustion is the opposite of photosynthesis. So if you think about all of these things that I mentioned, your coal, your oil, your propane, all of it really came from life. So fossil fuels are basically ancient solar energy, And so when we talked about photosynthesis, we'd said, oh, well, if you have some water for your plants and you have some CO2 in the atmosphere, plus light energy, we're going the opposite direction from this end to this end, you can then produce sugars and a waste product of oxygen. Well, combustion is read the proper way, the way it's written up here, in the presence of oxygen with a carbon-rich substance such as a sugar or coal. More importantly, we're going to be talking about coal or oil or propane. Once you get it burning, it's going to release energy plus CO2 plus water. And that is the formula that we're going to be talking about. When we talk about fossil fuels, well, they've known about coal for forever, basically. 200 years ago, London was suffering from air pollution due to the burning of coal and peat. It ends up oil. You know where it was discovered? Just north of here in Titusville, or not discovered. It was first, because there oil seeps in places all around the world, but this is the first place it was exploited. And so in Titusville, just north of Butler, is where it got its start. Okay, so we have potential energy is the energy that is stored in a molecule or stored energy just in general. Now, when we talk about combustion, it's going to be the molecules that are involved. And then when this stored energy that is in this carbon-containing molecule, when it is being broken into pieces, so you see this molecule here has 6 carbons, 12 hydrogens, and 6 oxygens. We're going to break it down into individual carbons, and then the hydrogens and oxygens, and we're going to release the energy. So when you release the energy, it's not potential energy, it's kinetic energy. All right, I'm going to stop right here.